Using the parent function f of x below, graph the new function after the transformation listed below. A. Vertical compression by a factor of 1/2. B. Vertical shift down 2 units. C. Horizontal shift right 3 units. If we let the transformation of the function f of x be equal to g of x, recall we can express g of x as g of x equals a times f of the product of b and the quantity x minus c plus d. Going back to our notes on transformations, here we have a list of how the values of a, b, c, and d affect the graph of f of x. You may want to pause the video and review these notes. For this problem, we'll go ahead and list the function rule for g of x, and then we'll perform the transformation. A vertical compression by a factor of 1/2 indicates a equals positive 1/2. A vertical shift down 2 units indicates d equals negative 2. And a horizontal shift right 3 units indicates c equals positive 3. Because we don't have a horizontal compression or stretch, b equals 1. Which means the function rule for g of x is g of x equals 1/2 times f of, because b equals 1, the function input is just x minus 3, and then because d is negative 2, we have minus 2. And now to perform the function transformation, we can perform them in the order as listed, a through c, or we could use the function rule and work our way from inside out. The final result will be the same. For this problem, we'll go ahead and perform the transformations in order from a through c. Before we do this, though, let's find 3 key points on f of x. For example, the vertex is the point 0, 0, and then let's use the point 2, 4 on the right and the point negative 2, 4 on the left. To perform a vertical compression by a factor of 1/2, we multiply all of the y coordinates by 1/2, starting at the origin. 1/2 times 0 is still 0. After a vertical compression by a factor of 1/2, the vertex is still 0, 0. However, for the points negative 2, 4 and 2, 4, because 1/2 times 4 is 2, after the compression by a factor of 1/2, we have the points negative 2, 2 and 2, 2. And if we graph the parabola now, notice after the compression by a factor of 1/2, the parabola is more wide, or again, it's been vertically compressed. Next, we have a vertical shift down 2 units, which also affects the y coordinate. We now need to subtract 2 from each of the y coordinates. Again, starting at the vertex, 0 minus 2 is negative 2. After a shift down 2 units, the vertex would be 0, negative 2. And for the remaining 2 points, because 2 minus 2 is 0, we would have negative 2, 0 and 2, 0. Now we have the graph of the parabola after a vertical compression by a factor of 1/2, as well as a vertical shift down 2 units. And then the last transformation is a horizontal shift right 3 units. This affects the x coordinates. For a horizontal shift right 3 units, we now add 3 to each of the x coordinates. Starting at the vertex, 0 plus 3 is 3. The vertex is now 3, negative 2. For the point negative 2, 0, because negative 2 plus 3 is 1, we have 1, 0. And because 2 plus 3 is 5, the point on the right is now 5, 0. And now we can make a nice graph of the transformed parabola, which we'll call g of x. I hope you found this helpful.